Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 6.4, which is going to deal with transforming linear functions. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to identify the transformation to a graph of a line given a transformed equation. So we're going to start with something like y equals x. I'm going to give you a new equation, and your job would be to go through and describe the change that takes place to that line. And then also, you'll be asked to write a new equation given a set of transformations. So for example, I would tell you either to shift the graph up or down to make it steeper or less steep, or to go through and reflect the graph, and you have to go through and write a new equation of that line based off of my description. So, before we jump into our examples for today, I want to go through a couple different explorations to build this concept for you before we jump into some practice. So, our first exploration is going to ask us to investigate what happens to the graph of f of x equals x plus b when we change the value of b. And in particular, we're going to take a look at translating, which just means shifting a graph up or down when we change the value of this plus or minus number at the end. So let's go ahead and take a look at our first part of this exploration, which wants us to take a look at the graph of f of x equals x. So that's going to be this purple line right here. And the two things we're going to look at for every part of the Explorer 1 and 2 is the slope and the y-intercept. So if we look at the slope of my line, first of all, based off the equation, my slope would be 1 because there's no number in front of x, and that implies 1. And if we look at our line, it just goes up 1 to the right 1, up 1 to the right 1. So my fraction would be 1 over 1, which just results in 1. So my slope of this line is 1, and then the y-intercept, that's going to be where it crosses the y-axis for this line, is at 0. So you want to keep this purple line in mind as we go through and talk about some different examples today, and as we go through and talk about the rest of this exploration. So the graph has a slope of 1 and a y-intercept of 0. What we're going to do now is we're going to add a number to the end of this. So it's either going to be plus 2 or minus 3, depending on the situation they give us. And what we're going to do is take a look at how that affects the graph. So I'm going to go ahead and move this on up so we can have that discussion. All right. So this next part tells us, given other functions of the form f of x equals x plus b, for instance, given f of x equals x plus 2, which is going to be this red line, and f of x equals x minus 3, which is the blue line, we need to go through and identify what these graphs have in common and what they have different. So the two things we're going to look at for the different explorations are, do they have the same slope or the same y-intercept, or do they have a different slope or a different y-intercept? So if we look at these two graphs, what do they have in common? Do they cross the y-axis at the same spot? Okay, this one crosses at 2 and this one crosses at negative 3, so they do not have the same y-intercept. The next thing, do they have the same slope? Okay, this one goes up 1 to the right 1, as does the blue line. It goes up 1 to the right 1. And if we look at both their equations, the slope on both of these lines should be 1 because there's no number in front of x. So what they have in common is they have the same slope. So then the follow-up question is, how are they different? Well, they cross the y-axis at a different spot, so that means that they have a different y-intercept. and their y-intercepts would be at 2 and -3. So if we go back to this f of x equals x, this crossed at 0 and its slope was 1. Look at f of x equals x plus 2. It crosses at 2 and its slope is 1. And then f of x equals x minus 3, slope of 1, and it crosses at -3. So as we change that number at the end of the equation, it's going to shift the graph up or it's going to shift the graph down. Same slope, it just shifts the graph up or down based off what that number is. So that's going to lead us into our first discussion point to kind of summarize this exploration up. So, a vertical translation moves all the points on a figure in the same direction, either up or down. So, what happens to the graph of f of x equals x plus b when you increase the value of b? Well, when you increase the value of b, like we did in the red line, the graph of f of x equals x moved up. So it shifts the graph up. So it's going to shift the graph up. And then the next point is going to ask when we decrease the value of b. Decreasing the value of b would be like what we did in the blue line, and that's going to shift the graph down. So anytime that number, like x plus or minus a number, increases, that moves the graph up. Anytime it decreases, it's going to move the graph down. So keep that in mind. Whenever we're talking about x plus or minus a number, if that number gets bigger, it goes up. If it gets smaller, it goes down. So let's say we started with the equation f of x equals x plus 7. And I want you to shift that graph down 2 units. That means you would take that 7, you're going to decrease it by 2, which would make it 5, so it would become x plus 5. Alright, so that's going to be the discussion on translations and what happens to a graph when you change the value of b at the end of the equation. Next, we're going to take a look at what happens when we change the value in front of x, our m value, and how changing the slope affects a graph. Okay, so our second exploration is going to do just that, where we're going to take a look at how linear functions are stretched or shrunk, or how we can reflect them by changing that value of m. So our investigation for this part is going to ask us to investigate what happens to the graph of f of x equals mx when you change the value of m. First, we're going to take a look at increasing the value of m, then we're going to take a look at decreasing the value of m. Alright, so this part states that they want us to go through and graph different functions in different forms of f of x equals mx, and we want to use values that are greater than 1. So if we have the graph f of x equals 2x and f of x equals 5x, that accomplishes that goal. So the red line is f of x equals 2x, and the blue line is the graph of f of x equals 5x. So what do these two lines have in common? Remember, we're looking at the y-intercept, so where it crosses the y-axis, and we're looking at the slope. So what do they have in common? Do they have the same slope? Do they go up and to the right the same amount? Well, the first one goes up 2 to the right 1, and the blue line is going to go up 5 to the right 1. So their slopes are different, so that is how they are different. So the question is, how are they the same? Well, they both cross the y-axis at 0, so that means that these two lines have the same y-intercept, meaning they cross the y-axis at the same point, which in this case is 0. So ultimately, as we look at these two lines, if we look at the red line to the blue line, the equation of the red line is 2x, the equation of the blue line is 5x, so the number in front of x has increased. So if we go from red to blue, the number has increased for the slope. So how does that change the graph? Well, as the value of m increases from 1, does the graph become steeper or less steep? In this case, and in all cases, the graph becomes steeper. If we look at it from red to blue, the graph is getting steeper and it's getting a higher incline. So any time that that value in front of x increases, that means that your graph is also going to get steeper. Now, the next thing we're going to take a look at is when that value in front of x decreases. So keep in mind, when the m value gets larger, your graph gets steeper. So the next part we're going to take a look at is going to talk about in terms of when the graph gets less steep. So, again, they want us to go through and graph different forms of f of x equals to mx, and we want to use numbers that are less than 1 but greater than 0. So if we have f of x equals 0.5x, which is the red line, and then f of x equals 0.2x, that's going to be our blue line. So if we look at these two graphs, again, they have the same y-intercept. They both cross at 0, but they have a different slope. And if we look at our equations, it's from 0.5 to 0.2. Okay, our number has decreased. So if our number decreases, what happens to the graph? Is my graph steeper or is it now less steep? Well, if we look at our lines from the red to blue line, okay, the red line got less steep because the value of m, the number in front of x, decreased. So as x increases, your graph gets steeper. As x decreases, your graph gets less steep. All right, now, before we wrap up and then go into our examples, okay, there's one last part to talk about, and that's going to be when a negative or the sign in front of x changes. So this part is going to talk about if we are given the function f of x equals x, so that's our red line in this graph, and then we look at the graph of the function f of x equals negative x, it's the blue line, what is happening? So how are the graphs of f of x and f of x equals x or negative x geometrically related? Well, they have the same steepness, they have the same shape, okay, they are just reflected. So how are they geometrically related? They have the same shape, and I'm going to sum up steepness as slope. They are just reflected, meaning I could reflect this red line over here and it would match up with the blue line, or I could reflect it over the x-axis. So describe what happens to the graph of f of x equals x when a negative is applied to the slope. Well, it's going to reflect the graph over the x and y axis. So any time that a negative is introduced or taken away, that's going to reflect the line. So anytime that you see a negative appear or disappear, your line has been reflected. Or if they ask you to reflect a line, you're going to introduce a negative or take a negative out of the problem. Now, for our last discussion point here before we sum all this up, anytime that the number of m is greater than 1, we are presented a vertical stretch. And anytime that the number for m is greater than 0 but less than 1, we are presented a vertical shrink. Graph gets steeper, graph gets less steep. And that's going to be the sum up of that point. All right, so let's take both of these explorations and kind of summarize it into a thing that we can look at and use as a reference for our homework. So to recap, if we started with this as our parent function, f of x equals x, and then we've now kind of expounded upon it to this f of x equals mx plus b, what happens to the graph when we change the value of m? So when we change that number in front of x, okay, when this number gets bigger or smaller, that makes the graph steeper or less steep. And then when we take a look at what we changed the value of b, so this plus or minus number at the end, it's going to shift the graph up or it's going to shift the graph down. So when you are looking at these problems, if the number in front of x gets bigger, it makes it steeper. When you look at the number in front of x and it gets smaller, that makes the graph less steep. When this number increases, the plus b, it's going to shift the graph up. When it decreases, it's going to shift the graph down. Now, the last point is an addition or removal of negative to the value of m. If we add a negative or if we remove a negative from this m value, that is going to reflect the graph. So that is the summary of everything that we have just talked about since the start of this video. And we're going to go through and apply that concept to our examples next. Alright, so with that said, let's finally get into our examples for today. And I'm going to shift this up here a little bit so we can reference it, at least for the first example. So example 1 asks us to go through and identify the steeper line. So for A, we have y equals 3x plus 4 or y equals 6x plus 11. Remember, when we are looking at steeper or less steep, we're looking at the change in m. So that's the number in front of x. So we have 3 and we have 6 respectively. So between 3 and 6, which of these two is a larger number? 6 is greater than 3, so the steeper line is y equals 6x plus 11. Alright, if we look at B, so we have negative 5x and then a negative 2x. Which of these are steeper? Don't think of it as the fact that negative 5 is less than negative 2. Just think of it as between 5 and 2, which one is greater? Okay. 5 is greater than 2, so that makes the equation y equals negative 5x minus 1, the steeper line. Don't worry about the fact that negative 2 is actually greater than negative 5. Just focus on between 5 and 2, which one is larger. Just like with 3 and 6, 6 is larger than 3, 5 is larger than 2. Okay, so example 2 is going to ask us to go through, and each transformation is performed on the line with the equation y equals 2x minus 1, and we need to write the equation of the new line. So they give us our starting point that the equation of a line is y equals 2x minus 1. We have to go through and write a new equation to apply these different transformations. So we have parts A through F that have different types of transformations, and we have to apply that to the equation. All right, for A, it states a vertical translation down 3 units. So we're just going to focus on the left side, then we'll go to the right side. So if we want to go down 3 units, okay, the part in this y equals mx plus b, if we're shifting the graph up or down, that's changing this value of b. Because we want to go down 3 units, we have to take this minus 1 and go down 3. So negative 1 goes to negative 2, negative 3, negative 4. So that means instead of minus 1, this is going to be minus 4. So this becomes y equals 2x minus 4, because I shifted my graph down 3 units. So I took that negative 1 and I went down 3 units. Now for part C, it wants us to divide the slope in half. So if we're going to divide the slope in half, well, my slope is 2. So if I'm going to divide that in half, half of 2 is 1. If I divide this by 2, 2 divided by 2 is 1. So that means my new equation is y equals 1x minus 1. Okay, all it asked us to do is to divide the slope. It didn't ask us to go through and change the translation. All right, for part E, it wants us to increase the slope by 50%. So how you're going to do this, if you're ever asked to increase the slope by 50%, okay, our slope in this case is 2. So we're going to take 50% of 2. So we're going to do 2 times 0.50, which gives me 1. So 50% of 2 is 1. So then we're going to do 2 plus 1, and that gives me 3. So that means my slope needs to change from 2 to 3. And that's the only thing that's going to change. So this becomes y equals 3x minus 1. For A, it just wanted me to translate the shape or the line down 3 units. Never said anything about steeper or less steep. So my slope stayed the same. The y-intercept changed. These two are just talking about changing the slope. So this minus 1 stays the same from this graph. All right, so if we look at the right side. So for part B, it wants us to increase the slope by 4. We're going to increase the slope by 4. My slope was 2. So if I'm going to increase it by 4, 2 plus 4 is going to give me 6. So my new equation is y equals 6x, and the minus 1 stays the same. All right, for part D, it wanted us to shift the graph up 1 unit. Again, shifting a graph up or down is going to affect the plus or minus at the end. So because this is minus 1, to shift it up 1 means we need to add 1. So negative 1 plus 1 would give us y equals 2x plus 0. or y equals 2x. Now, if they wanted you to shift it up anything more, okay, we would then move up into the positive numbers, as we see with f. So for part f, it's going to ask us to go through and do two different types of transformations. So they want us to shift it up 3 units, and then the slope needs to be doubled. So we're shifting it up 3 units. That means this part needs to move up 3, and then the slope being doubled. So the slope needs to be doubled. So a doubling of 2 means that we're going to do 2 times 2, which is going to give us 4. So y equals 4x. And then shifting the graph up 3 units, we're going to take this negative 1, we're going to move it up 3. So that means we take negative 1, and we add it by 3, and we get 2. So my new equation would be y equals 4x plus 2. Whatever it wants you to increase or shift the graph up by. If it wants you to shift the graph up, you're going to add to whatever your y-intercept here, this plus or minus number, you're going to add how much it wants you to shift up to that number. If it wants you to shift it down, you're going to subtract. If it wants you to increase the slope, that means you just add that number to the slope. Doubling, tripling, quadrupling means that you're going to multiply. And taking away would just be dividing to that slope or subtracting. So, example 2, that is the second part of our learning goal where it wanted us to go through and write a new equation based off of given transformations. So, example 1 and example 2, we have identified which one is steeper or less steep. And then we've also talked about how to transform an equation given a transformation. All right, last set of stuff for today, examples 3 and 4. Now, a little bit of terminology before we jump in to example 3. A parameter is one of the constraints in a function that determines which variation of the parent function one is considering. For functions in the form f of x equals mx plus b, the two parameters are m and b. So the two parameters are the slope and the y-intercept. So it wants to know which one is left unchanged or which one is changed. You have to go through and state, does the slope change? Does the y-intercept change? Or does the slope stay the same, or does the slope change? So that's what it's going to talk about. All right, so I'm going to slide this on up, and I'm actually going to take away all the wording for example 3 and just kind of go through and explain what it wants. So if we look at the first graph, so we have 3 different lines graphed, y equals 2x plus 2, y equals 2x, and then y equals 2x minus 1. It wants us to describe the parameter that is left unchanged in the equations of the line of the first graph. So based off of this, is the slope left unchanged, or is the y-intercept left unchanged? Do they cross the y-axis at the same point? They don't. Are they all parallel lines? They are, because they never cross or intersect. So that means that they have the same slope. So the part that is left unchanged is the slope, because they have the same slope and a different y-intercept. Now, if we look at our second graph here, okay, what is the parameter that is left unchanged of y equals negative x plus 1, y equals 2x plus 1, and y equals x plus 1? Well, all of these cross the y-axis at the same point, And because all of these lines intersect and cross each other, that means they don't have the same slope. So the parameter that's left unchanged is the y-intercept. So they have the same y-intercept and a different slope. So when you get to the questions that are going to ask you what parameter is left unchanged, if your graph looks something like this, the slope, or our m value, is left unchanged. If your graph looks something like this, your y-intercept, or your b value, is the parameter that is left unchanged. All right, so that is example 3. So when you get to the questions that ask you to describe the parameter that is left unchanged, use these two as a reference to tell you whether the slope or the m value is unchanged, or the y-intercept or b value is unchanged. Okay, last one, example 4. In example 4, it states the following. A gym charges a one-time new member fee of $50 and then a monthly membership fee of $25. The total cost, C, of being a member at the gym is given by the function C of t equals 25t plus 50, where t is the amount of time in months since joining the gym. For each situation described below, sketch a graph of the new situation. $25 per month, so 25 times t, and an initial membership fee of $50. Now for part A, it states the gym decreases its one-time fee. If it decreases its one-time fee, that means instead of $50, it would be something like $25. So instead of initially paying $50, that would be like paying $25. So how does this go through and change the graph? Well, it crosses the y-axis at a different point, but my slope is going to be the same. So that means my graph will look something like that. Now, for part B, it talks about if the gym increases its monthly membership fee, we still start at 50, but if we're increasing the membership fee, that means my graph has a steeper slope, and it would look something like that. So if we're decreasing a one-time fee, the graph just shifts down. If we're increasing the monthly fee, that means it starts at the same point, but it's increasing more rapidly. All right, so that is, in fact, our notes for today, and that is all that I have for you guys for today's lesson and today's video. Again, just to kind of sum up what we talked about. If we start with the equation y equals mx plus b, anytime that this value increases or decreases, it makes the graph steeper or less steep. Anytime that this number increases or decreases, it shifts the graph up or down. So the number on x, if it gets bigger, it gets steeper. Smaller, less steep. The number that you add or subtract to x, if that gets larger, it moves the graph up. If it gets smaller, it moves the graph down. And know that a sign change in front of x, if it goes negative, it's going to flip the graph and reflects it. So that is our lesson for today on section 6.4, Transforming Linear Functions. As always, I highly suggest you reference the completed notes as you work on your homework. And if you have any questions, as always, just let me know next time you see me or via email. So that is it for today. Thank you guys for listening, and I hope you have a great day. All right, bye.